Hello and welcome to Krad Math. Today we'll be going over construct an NPDA given the language. So first thing we do is always try to understand what is being asked right here. What does this even mean? Well, this means give a word. Actually, it says give a word, then give a C, then give that same word but reversed. That's what that R means right there. And we can only use A's and B's, and of course that C right there. So for example, a word like A, B, C, B, A would be accepted. So let's keep this in mind here when constructing the NPDA. So we want to make 3 states. Okay, so the first state right here is going to be, oh, whoops, I erased it. The first state here is going to be building the word at the front end. Then the pathway here is going to make the C. The state here is going to then pop the words, it's going to input words, popping things off of the stack, giving our word reversed. So that may sound simple or it may sound difficult, but don't worry about it. It's not too hard. Right when we start, we want to write down the words and the stack. To avoid confusion, I'll be writing down words with a lowercase letter and stacks with a capital. Just to avoid confusion, our stack always begins with Z, and let's go on forward. So first we want to put an A into our word that pops a Z off the stack and then inputs an A and a Z. We want to do the same thing with B. So, So what this means is that when we run this, it puts an A on our word, removes the Z because of this right here. This means remove a Z, and then this means add an A and a Z. So the Z gets removed, but it gets added back, and then we have an A on the stack. If we then run B, it does the same thing, but we can't run B just yet. So the reason why we can't run A and then B is that this B here requires to pop a Z off of the stack, and the top of our stack is an A, so we can't really run this at all. So we need to write an extra, a few extra lines. So we're going to be moving this down. Hopefully there's enough space. There will be. So what we'll be doing here is yet another A, another B, and these will be popping off an A from the stack, while this line adds an A, and this line would add a B. So now we can add in a B using this line, which adds a B to the stack. But what if we want to add in an A? If we want to add in an A or a B, we can't, because the top of our stack is a B. None of these pop B off the stack. So we need to make 2 more lines. Another A, another B. Both of these pop B off of the stack, while this one adds an A, takes the B, adds a, sorry about that, adds B's. So now we can then add in an A or a B if we just add in B, because it pops this B off the stack, but then it gets added back in, and we can write a B. And if we want to write an A, all good. So that's what we have so far. So far, this here works, right? This part's done. because it allows us to add, oh, whoops. Because these lines allow us to add right when we only have a Z on the stack. These lines allow us to add words when we have an A on the stack. These allow us to add words when we have a B on the stack. And since we're only dealing with A's and B's, that's as far as we need to go. If we had to deal with D's, E's, we have to write this whole thing and it'd be long. Now, when traveling from, let's just call this the start state. This is D because why not? And the F because it's the final state. When traveling from the start state to the D state, what we want to do is let's just add in a line. We can put C as the word. Then, C as the word that accepts a Z popping off the stack and puts in a Z. And then, what's going on here? Same thing, but for A, and I'll explain why we're doing this. The same thing for B. So the reason why we have this right here is that it doesn't matter what's on the stack. We can have a Z on the stack or an A on top of the stack or a B on top of the stack, but a C gets added either way. Doesn't matter. So that's why we have it. The reason why we have Z is that if we don't do anything here, we then move onward and we still have a Z on the stack, and this language also needs to accept not doing anything. Now, once we're at this state, and let's just say that our word so far, let's keep it simple. Let's just say our word is A. We had an A right here. Then it is B. Add in a B. I always write my B's messed up. And let's just say that's our word, okay? Because, again, we're trying to see if we can write this out, okay? So we have BAZ on the stack and AB as our word. One minor detail or major detail, make sure this loops around, and we want to make sure that this loops around as well. And we want to make a line right here. So this part's simple. We add in a line that adds an A onto our word, then pops an A off the stack and doesn't give anything back. That is a lambda, not an X. It's a lambda. Let's see if we can do better. Okay. The same thing with B. That takes a B off the stack and adds in nothing. So, when we run this line right here, it basically adds in a C. It takes away this B, but then it puts it back in. So our B stays there because we run, because we run this line because B is at the top of our stack right here. Nope, don't want to do that. Let's run these lines. We have a B at the top of our stack, so we're going to run this one right here of inputting B and removing B from the stack. And then we're going to do this A line right here by adding an A and removing this A from the stack. And now we only have a Z in the stack. We have one more thing to do, is by making a pathway that adds in a lambda or nothing to our word, takes a Z, and adds in a Z. Just want to make sure that's all right. This may not look perfect, but this is the answer is right here. This is the NPDA that you construct, and writing down the word in the stack is just a good way to keep track of what you're doing. So I hope this helped. If this helped, like the video. I hope you guys enjoyed this and learned a lot from this. and stay tuned for more math videos. See ya.